Tell you. All right, so those will take place. So number 6 we did together, so that's kind of a special way. And then you get to problem number 7. Okay, this is one I asked you to give a try yesterday. And number 7, you're like, it's x to the 3rd stirrup, it's not going to factor. Well, okay. So you might think, let's see. So I have 6x raised to the 3rd plus 8x squared. And then I have minus 8x. So it looks like this. So we have this fancier looking contraption. So I have roots at those spots. Now, x minus 2, or x equals negative 2, x equals 0, and then we just said that 0.667 is the same thing as 2/3, right? So negative 2, 0, and 2/3. So x equals 2/3, x equals 0, and x equals negative 2. Okay, so this is going to turn into 3x equals 2, which gives me the binomial 3x minus 2. If I get x equals 0, I can't move the 0 over. It's not going to change anything. So that means there's an x out front. And then this one gives me the binomial x plus 2. And friends, we just factored it. My gosh, now you're probably getting all mad at your Algebra 1 teachers and your Algebra 2 teachers because they just didn't show stuff this fun or this easy. Now, if this isn't coming easy for you, let's work with it. I bet you we can get you to a point where you'll start feeling more and more confident with it. All right, then we get to number 8. Now, some of you might recognize number 8 as the difference of two squares. Fantastic. I love you for it. But let's see what Desmos does with number 8. So I'm going to go y equals, and I have x to the 4th, and then minus 1. So you got this weird-looking, flat-looking parabola. Agree? So you definitely have a root here, and you have a root here. Both of those roots exist. Something else is taking place, though. Okay? Now, did you, in your previous years, did you ever hear the terms bounce, wiggle, cross? That's something you heard? This is just two different crossings, which means if there are two different crossings, that means that I have a binomial once that would take place. I don't have a bounce, so it's not taking place an even amount of times, and I don't have a wiggle, which means it would take place higher, 3 or 5 or 7 times. Okay, so far I just have this. So I have x equals -1 and x equals +1. So this gets me x plus 1, and this gets me x minus 1. Okay, and if I foiled this out, this would just give me x squared minus 1 if it was foiled out. But our problem is x to the 4th minus 1. So we've taken care of 2 of these, and there's 2 more left. So we have to kind of think, how can we figure out what might take place with this? And that's going to lead us into a little bit of today, trying to work it out. Okay, so I have x to the 4th, which basically means I have x to the 4th plus 0x to the 3rd plus 0x squared plus 0x minus 1. Okay, 0 times x to the 3rd is just 0. 0 times x to the 2nd is just 0. 0 times x is just 0. Okay, so I have placeholders in place. The number I have sitting out front here is a 1. Agree? So what I'm going to do is this. I'm going to take -1 and +1, and I'm going to use synthetic division. So I'm going to put my -1 out here first. And I'm going to put my lead coefficient. So I have a 1, I have a 0, I have a 0, I have a 0, and I have a -1. Does that make sense? Just how I got that. Have you seen synthetic division ever? Don't let the word division mess with you, because synthetic division is like the friendliest version of dividing I've ever seen in 28 years of teaching. And if this ding-dong of a teacher could have figured it out, I bet you can. So first thing I'm going to do is I'm going to draw an arrow. This comes straight down. Make sense? 1 times negative 1 is negative 1. Add these together. 0 added negative 1 is negative 1. Negative 1 times negative 1 is positive 1. I'll bring a 1 down. 1 times negative 1 is negative 1. 0 plus negative 1 is negative 1. Negative 1 times negative 1 is positive 1. Negative 1 plus that. If I get my very last term being a 0, that means this is a guaranteed root. Okay? So that verifies, this verifies right now that x plus 1 is part of my binomials. Okay, let me just pause there for a second because I kind of just saturated you with a whole different thought process. Is there anything that I've done so far on the board that you're not quite sure about? Okay, so now I'm going to synthetically divide using just this. The reason I'm only using that only is because my end result was a 0. Okay, so I've already taken care of this, so I don't want to worry about that. So I'm going to now have this 1. So I'm going to go 1, use my weird looking division sign. Now I'm going to plug in those values. So when I do this, this 1 comes straight down. 1 times 1 is 1. Negative 1 plus 1 is 0. 0 times 1 is 0. 1 plus 0 is 1. 1 times 1 is 1. I get a 0. This gives me a 0 back here. Okay? So now this verifies that this is also a root, which leads me to x minus 1 as a binomial. And I'll highlight that in yellow. Okay? Now we have to think a little bit deeper. Okay. Originally, this first thing here that I synthetically divided was x to the 4th power. Agree? I used synthetic division and I got this. That means that this down here would have been x to the 3rd. If I rewrote this, put the x's back in, I'd get 1x to the 3rd minus 1x to the 2nd plus 1x minus 1. Okay, so this went from being 4th degree to a 3rd degree. What degree is this then? This was 4th, this was 3rd, this is now a squared, 2nd degree. So x squared plus 0x plus 1. Okay, so what I mean, let me reemphasize what this means. So this was my original when I put my zeros in place. Agree? This is going to be what this would have been. Oop. Looked at the wrong thing. I'm sorry. And then that then changes this to 1x squared plus 0x plus 1. Okay, I only had 2 places that it crossed. It didn't bounce or wiggle at either of those. So that means that there has to be some other root that takes place. Well, let's clean this up a little bit. This becomes x squared plus 1. And friends, what can you tell me about x squared plus 1 from your days of Algebra 1? Is it the difference of 2 squares or is it the sum of 2 squares? It's the sum. Does the sum of 2 squares factor? No. So that means my factored version of this is going to be those 3 things. So I have x squared plus 1. That won't factor. And I get x plus 1 and x minus 1. Now, the order of these does not matter how you write it. I know there are some teachers that are like, oh, put the highest degree first. It has to be that way always, always, always. And you're like, dude, why? Just because. No, that's not an answer. That's like getting into the nuh-uh, yeah, huh argument. Okay? That's the answer to this particular problem. Synthetic division is a valuable tool to use Utilize Desmos to do the synthetic division to start breaking things down further. Figure out where it's crossing the x-axis. Okay? All right, and then I have to do number 9 still. Is there any questions on that one? This was a much different problem to think about. Okay? And I'm not trying to make it more work. I'm not, finding joy saying, hey, now I have synthetic division. This is going to, punch you in the throat and you're going to love it. No, don't do that. That's just kind of how you have to smother through it. Now, the nice thing is, what did I say about tests and quizzes in here? Yeah, you do. It's going to be on Desmos. You have 20 minutes on your own. Give me 20 honest minutes you trying to work it out using your open notes, open book. And then the rest of the class period would then be a compare, share, and revise, meaning you get to work amongst yourselves to try and get the best score possible. And I can assure you the conversations that you will be learning off of each other to reinforce what we did. Okay? Does that mean everyone gets an A? Not necessarily. Okay? I mean, if everyone got an A, I only had one class this year that everyone got an A in. You two are in it. My medical class. Everyone got an A. I was the first year in many years. Yeah, I often get a lot of people that they just miss like 30 times. And it's like, then their parents are ticked that the kid didn't get an A. I'm like, your kid has to show up. Well, that's not fair. Isn't there something they can do to make up the points? No. All right, number 9. Number 9, let's plug it into Desmos, see what we get here. All right, so I'm going to add the y equals, and then I have 6x raised to the second. Arrow down, plus 10x, minus 4. Okay, this one worked nicely. I don't know why there's 2 of those. What is 0.3 as a fraction? 1/3. Okay, so I have 1/3 for this one, and I have -2 here. So I get x equals 1/3 and x equals -2. Is that right? Multiply both sides by 3 here, so I get 3x equals 1. So I get 3x minus 1. There's my first. And this gives me x plus 2. It's factored. Cool. All right. Will you turn the page? I'm on the page that there's only 4 problems on. Problems 16, 17, 18, 19. Which one should we try? So notice it has the word synthetic division at the top. Well, it's not going to stop us from using Desmos. So what I'm going to do is let's take a look at number 17. You with me on this one? So we're going to take a look at number 17, which is x to the third plus 3x squared minus 6x minus 8. I'm going to tell you, before technology came available for us, there was a mathematician named Descartes. Descartes, that's how we say it. But Descartes basically said this. Okay, what you have to do is you have an xy axis. So follow me on this adventure. On this xy axis, anything that's to the right of the y-axis is going to be called a positive root. Anything to the left of the y-axis is going to be called a negative root. Still following this adventure? So what Descartes did is said, okay, I have positive to positive, no sign change. Positive to negative, 1 sign change. Negative to negative, no sign change. That means I have 1 positive, so to the right of the y-axis, crossing of it. Now we don't know what it is. And then what Descartes realized is if you plug negative x in and do the math, so you get negative x times negative x times negative x is negative x to the third. Negative x times negative x is x squared. Negative 6 times negative x is positive 6. and then minus 8. You go through the sign change there, and you find your negative sign roots. Okay? And then you take all of the factors of your very last term over all the factors of your leading coefficient. So your factors of 8 are 1, 2, 4, and 8. And your factors of 1 are positive 1 and negative 1. And you synthetically divide each one. So technically, we should have 3 crossings of the x-axis if we have 3 rational roots. Meaning a rational, meaning a decimal or a whole number that can be written as a fraction. The decimal is a fraction. Okay? It was a lot of work. Okay? But in today's age, we have the technology that gives us a visual representation. So the nice thing about how the technology is now is going through and actually doing Descartes' rule of signs and figuring out the positive and negative roots by using synthetic division. It was a lot of work. And there was times that you might have a double root that takes place, which creates a bounce. But we couldn't see bounces, wiggles, and crosses as easily back before we had the technology to do it. So let's utilize this information with Desmos and let's see if we can get it to work. So I'm going to do y equals x raised to the third. Ooh, what is that right there? It's a wiggle. Everyone agree? Okay. Now, it's not guaranteed to stay there. I'm just pointing out that that takes place. 3x squared minus 6x minus 8. Okay. Here's the beautiful thing. How many times was it supposed to cross the x-axis, and how do I know? It's supposed to do 3. Why 3? Because my highest powers are 3. Cool. So that means that the negative 4 is x plus 4 as a binomial. Agree? The negative 1 is x plus 1 as a binomial. The 2 is x minus 2 as a binomial. And that's how it would factor out. So you could go through and synthetically divide these, but if you had one that you weren't able to quite see what it would come down to, you would have to use synthetic division. So let's just for the fun of it, I'm going to synthetically divide with the negative 4 and see how it would work from there. So I'm going to take the negative 4, and I have a 1, I have a 3, I have a negative 6, and I have a negative 8. The 1 comes straight down. 1 times negative 4 is negative 4. Add these. Add those. That's negative 1. Negative 1 times 4. Negative 4 is positive 4. Add those. So I get negative 2. Oops. Where'd you go? Negative 2 times negative 4 is positive 8. And because I got a 0 down here, that means something. Now, here's a few things to just realize what this is showing. This is showing me right now that negative 4, comma 0 is a point on our graph. Now, some people thought back in the day, let's just pick an arbitrary number. Let's pick 10 and do synthetic division with our 10 of just our original. Okay? Now, I know 10 doesn't work because it didn't work on our graph, but let's just show what this shows. 1 times 10 is 10. That's going to give me 13. 13 times 10 is 130. That's going to give me 124. 124 times 10 is 1240. Add those. So I get 1, 2, 3, 3, 2. Oh, no! It's doing that to me. Okay, so that's 1032. So this is what this means. 10, will you write that down for me? 1232, you have it? So will you write down the point 10, comma, 1232? Okay? Okay, so what this means, the point 10, comma, 1232 exists on my graph. Okay, let me show you how that works on Desmos. I'm going to put a table in. And I had 10 and what?
1232.
1232. I'm going to hit the plus button. So our graph is like way down here. We can't even see it wiggling and stuff. This point right here is the point 10, 1232. That means the point 10, 1232 exists on our graph. Now, things that will take us into more of the calculus idea is if I were to pick one number and do synthetic division and it becomes negative for my very last number, and I would pick the next number over, and I did synthetic division and it came out positive, I have a sign change in my very last number, which means between those two numbers, it has to cross the x-axis. And that's kind of a calculus idea that's going to start taking place. And that's where we would start getting something called a sign line. We're not there yet, but we'll just talk about that. So what do we say for tomorrow? And I will mark this off. Being that you are here today, if you're here today, I'm going to put in those first 9 problems. I'll go in the grade book for you. I'm figuring you've done it. So will you take a look at, I got to go to this. Where's my keyboard? Keyboard. There. Because my thing is getting goofy on me. Keyboard. Okay, so what do we say we do? Algebra 1 review. And hit upon the odds. So that would mean that on the first page you need to do 11, 13, 15. Now on the back page, I think we already did 17, then that would leave you 19. So that gives you about 5 problems to give an attempt to. Which I only gave you 3 minutes left, so I'm that big jerk of a teacher. He's like, sir, if you didn't give us any time, it's only second day of class. That's why I only gave you the odds. Just give that a good try. See if you can figure that out.